Let's talk about the Laplace transform. When you have a function f of t that you wanna move it into a function as f of s, in this case we say the Laplace for the function in terms of s will equal the integration from 0 to infinity of e to the power of minus st multiplied by f of t dt. So finding this integration, this is the basic form of finding the Laplace transform. Doing that, you will be able to find the Laplace transform of any function that's written in terms of t. Let's take a simple example. Let's call it a generalized example. So we have a, this a is considered a real number. Then you have your function in terms of t equals e to the power of a multiplied by t. Now you want to find the Laplace transform for that function. So you can say the Laplace of the function in terms of s equal the integration from 0 to infinity of e to the power of minus st, which is the one in here, multiplied by f of t in this case, e to the power of at, all the integration in terms of t, in this case dt. Okay, trying to simplify the form of the integration, so we can say the integration from 0 to infinity again of e to the power of a minus s multiplied by t dt. Right? Now this equals the limit of k approaching to infinity for the integration from 0 to k of e to the power of a minus s multiplied by t all dt. Solving this limit and this integration will give you minus 1 over a minus s, which equals 1 over s minus a. So the scientist made it easier for us. So there is somebody who did all this analytical solution, and these scientists, they created a table. So in the next time when you have e to the power of at, you know that the Laplace transformation for the e to the power of at is equal to 1 over s minus a. And this table can be shown in here. So you can see here, this is the function in terms of t. Function number 1, 2, 3, 4, all the general forms of functions that you face in the day-to-day problems in mathematics are already transformed in terms of s. So you can see the 1, the transformation in terms of Laplace for the 1 equals 1 over s. So if you go back in here and you follow the same procedure, you can find the final solution to be, if you solve for 1 to be Laplace transformed, it will give you 1 over s. You can see here e to the power of at, it gave you 1 over s minus a, and this story continue. So from now on in the future lectures, we will not go through this analytical long method. There's somebody who made that effort for us. So we'll just basically use that table in order to solve a bigger problems in a faster time and more efficient way. Okay, sometimes you have a function f of s that you wanna reverse it to be a function f of t. That's what we called Laplace, inverse Laplace transform. So if you need to do an inverse Laplace transform, so in that case we can represent it as L to the power of -1. It's a well-known convention that it's an inverse, especially in matrices. The Laplace inverse for a function capital F equals a function small f. In that case, if you have a function f of s, let's say equals 1 of s, using the table in here, we can see, okay, function f of s, we have it as 1 over s. So the function f of t, what is it? So we know that f of t equals 1. In some cases, plus constant, depend on what kind of equation you're solving. So that's a good start for Laplace transformation. We'll continue on more lectures regarding this topic. It's an important topic in mathematics and especially in advanced engineering mathematics. So we will be solving initial value problems in the future using certain techniques that will help us find Laplace transformation or the inverse Laplace transformation for any problem that we face.